When the query optimizer processes a query that contains a join operation, it may choose to optimize the query by using a merge-join algorithm. In this example, the member table and payment table are joined on the member number columns. The columns used to join the tables are converted to two lists of ordered input values by the merge-join operation. Notice that the input values in the m.member_number are unique values, while the input values in p.member_number are not unique. These tables represent a one-to-many relationship. For one member, there are many payments. The query optimizer compares the first value from the input A to the first value from input B. If the values are equal, the matching rows will be returned. If the value from input A is less than the value from input B, then the query optimizer gets the next input value from input A. If the value from input B is less than the value from input A, then the query optimizer gets the next input value from input B. Because 1 is the lower value, 1 is discarded, and the next value in input A is used for the next comparison. The query optimizer evaluates that 2 is equal to 2. When the input values are equal, matching rows are returned. The next input value, 3, in input A, is compared to the input value 2 in input B. Because 2 is the lower value, 2 is discarded, and the next value in input B is used for the next comparison. Again, because 2 is the lower value, 2 is discarded, and the next value in input B is used for the next comparison. The query optimizer continues with this evaluation process. It compares the next input value in input B, which is also 2. Input value 2 is discarded because it is a lower value, and the next input value in input B is used for the next comparison. The next input value in input B is 4. The query optimizer compares the two values. Because 3 is less than 4, 3 is discarded, and the next input value in input A is used for the next comparison. The query optimizer evaluates that 4 is equal to 4 and returns all matching rows. The next input value, 5, in input A is compared to input value 4 in input B. Because 4 is a lower value, 4 is discarded, and the next input value in input B is used for the next comparison. Again, because 4 is lower value, 4 is discarded, and the next value in input B is used for the next comparison. The next input value in input B is 8. The query optimizer compares the two values. Because 5 is less than 8, 5 is discarded, and the next value in input A is used for the next comparison. The query optimizer continues with the evaluation process. It compares the next input value in input A, which is 6. It discards that input value and uses the next value in input A for the next comparison. As you can see, the query optimizer continues down input A, comparing the next key value to input value 8 and discarding the lower value. The query optimizer continues with this process until it finds that input values that match. Because 8 is equal to 8, the query optimizer returns the rows. The next input value in input A is 9. Because 8 is the lower value, the query optimizer discards that input value and uses the next input value in input B for the next comparison. The query optimizer compares the input value in input B, which is also 8. It discards that input value. Because all rows from input B have been processed, the query optimizer stops evaluating the remaining values in input A. The results from the merge-join operation can then be used by the next step in the query plan, such as a bookmark lookup or another join operation.